Okay, so this is a printout. You should have them available. You can go ahead and put that in your notes. This is a continuation of 4.1. So just pick up wherever you left off. So basic trig integrals. So they are based off whatever our derivatives are. So remember, we have a list of derivatives. So you don't need to write these down because you have these in your chapter 2 notes. But look at these derivatives, okay? This is where our trig integrals are based off of. The derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared, and so on. We can see this list. For integrals, we can only work this list backwards. In Calc 1, that's all we do. We don't do, like you're not going to see the integral of just secant. You're going to see the integral of secant squared. Our answer is going to be tangent. Answer or integral of negative sine is going to be positive cosine, or if we integrate sine, it'll be negative. So we can only integrate all of these things, do the antiderivative of what was our derivative in the first place. So when we integrate, we're going to have to see one of these 6 things over here that I just circled in green. So when we look at our integrals, integral of cosine is sine. Okay. Integral of sine is negative cosine because there's a negative in this relationship. Okay. Then the next one, we're going to integrate secant squared is tangent. We can only work this list backwards. So then we integrate cosecant. Oh, they're in the wrong order. Cosecant squared will give us cotangent. Oops, come on. Will give us cotangent. And then secant squared will give us, oh, that's typed wrong. No. Okay, fix your list. This is secant x plus c, not tangent. Oh. Okay, fix that. Dang it. All right, well, it's secant. And then you can integrate cosecant squared, cotangent, we just talked about that one. And then our last one, you can integrate cosecant cotangent, and that's negative cosecant. So those are the only 6 things that we can integrate. You're not going to be integrating just regular secant. It has to be secant squared because that's kind of on our derivative list. Antiderivatives, we can only undo derivatives. The only derivatives we had were these 6 things, so those are the only integrals we can do. Okay. So a couple examples, like basically these are just formulas, but I want to do 2 examples to make sure we know what's going on. So if we're integrating x squared plus secant squared x dx. So practicing our squiggle integrals, make sure you have dx on the end. This is our example. Now the first part of this is just our regular power rule that we talked about in the last piece of our notes. X squared, we can integrate that. We add the exponent, that's going to be power rule. Then the second part of this is where we use trig. So we just do one and then the other. So to integrate x squared, we have x cubed over 3. To integrate secant squared, we look at our list. Secant squared is here. The integral is tangent. So we have plus tangent of x, and then our BFF, c is on the end. When we integrate multiple things, you don't have to have multiple c's. They just kind of all combine at the end into one. Okay. The other thing that happens sometimes is that when we are integrating trig, x is not always our variable. So if we integrate, let's say, sine theta plus theta cubed d theta. Now d theta. Theta is our variable. So theta works just like x did in the previous problem. So the integral of sine, when we go up here, the integral of sine is going to be negative cosine. So negative cosine of theta. Plus, we need to integrate theta cubed. There is no trig with that. It's not a trig rule. It's just power rule. So this is going to be theta to the fourth divided by 4. And then we have plus c on the end. So it's pretty much exactly the same as this one, except for x, we have theta. Okay. Now, when we are taking integrals, sometimes we have to rewrite, just like we had to rewrite when we were doing derivatives. So what's going to happen? Oh, we don't want that yet. I'm going to move this. That's going to be a printout in just a minute. But our process, when we have some equations, our integration process. So what's going to happen is we're going to have our original integral. So our problem that we're given. Then, just like derivatives, it's not going to fit our rules. So the next thing that you're going to have to do is we're going to have to rewrite. So we're going to have to use those skills that we learned when taking the derivative. It's going to be the same thing when we take the antiderivative. After you rewrite, then you can actually integrate. And then you kind of undo your rewriting by simplifying, just like we did with derivatives. So you have a printout that has these columns already on there. We're going to do 3 together. So we're going to integrate these 3 problems. We're going to rewrite, integrate, and simplify. So this is kind of more structured, and then when you're solving the problems on your own, you need to be able to do these 3 steps, like just kind of on your paper. So this first, just like when we're taking the derivatives, we want them in the same format. We have a quotient, so we need to be able to rewrite this. So when we rewrite this integral, we're going to bring that x cubed up with a negative exponent. We have not integrated, so our integral still needs to be there. We've only rewritten. So our squiggle and our dx are still there, sandwiching in our x to the negative 3. Now we can integrate. When we integrate, we no longer have the integral. So we're going to have integrals here and here. But when we integrate, this is just going to be our answer. Okay? So when we do this process, integrating means adding 1 to the exponent. So that's negative 2 divided by negative 2 plus c. As soon as you have plus c, you do not have your integral anymore. Those can't be in the same thing. Those are separate. Then you can simplify. This is a negative exponent, so this can move to the bottom. So this x can move to the bottom. The 2 is already down there. So it's negative 1 over 2x squared plus c. Okay. Our next one, how do we rewrite that? We have a square root. Well, we're going to rewrite that as a 1/2 power. We have not integrated yet, so we still have our integral symbol. Our next step is actually integrating. So we're going to add 1 to our exponent. Adding 1 to 1/2 will be 3/2. Dividing by 3/2 plus c. Our integral is gone. Now we have plus c. To rewrite this, we keep change flip, so we flip 3 over 2 to 2 over 3, x to the 3 over 2, so those will always be opposite whenever you have a fraction. They will not be the same, plus c. So make sure you have plus c on both of those second 2 steps. Then we have a trig. This time we have a number in front. Well, numbers are just numbers. So when you rewrite this, just move that 2 out to the front and worry about it later. You're only integrating sine x dx. So we integrate sine, and we have 2. When we integrate this, we have negative cosine. And then you have plus c on the end. To rewrite this, it's really just multiplying the negative and the 2. So you have negative 2 cosine of x plus c. Okay. So that's the end. You have a worksheet to work on after you finish these notes.